Hello, and welcome to Ethereum Core Developer Meeting number 95. I'm your host, Hudson Jameson. We have a jam-packed agenda for today. Um, if you haven't already, check out the agenda. There's a note from me and James Hancock about YOLO v2. And there's a list of EIPs that may be up for consideration for YOLO v2 based on feedback from last meeting and various chats since last meeting. Um, so that's going to be important to look at. But let's go ahead and just go to the main agenda where we're going to be addressing many of those EIPs in general. Um, the first one is I have potentially removing gas refund, but I think, Alexi, did you say in chat to skip that one or another one?
Yeah, that one. But if you want, I can just give 1 minute summary, and then
Yeah, sure. We can do it.
we're not gonna have a discussion. But it's just I just say why I'm not ready yet for the discussion.
Yeah, go right
Yeah.
ahead.
So okay. So something came up that I didn't appreciate recently. So it came up yesterday actually. So I was always unconcerned about things like gas token and chi or whatever you pronounce it. And so yesterday somebody gave an idea, or somehow I came to the idea that I started to look at the transaction pool, and I saw quite a lot of transactions which were essentially minting, like they were pending transactions and they were pending to mint chi tokens or gas token too, and they were set at different prices. And so in my mind, I imagined it as like a kind of order book. So this is how I realized that transaction pools is basically like one-sided order book where you bid for the sort of for the gas prices. And then I sort of realized that if it was a order book, then essentially those orders placed in a particular placed in a particular orders are to make sure you basically buy the dips. Like in the traditional two ways order book, you would if you were like a whale or something, you would put a lot of um, low bid orders, so just in case that the price will fall, and then you just scoop those dips basically. And I thought the same analogy could be applied to this minting of this gas tokens. And but then of course I realized that there's a complication there. Usually on the exchange you can cancel the orders pretty much at no cost. But in a transaction pool, in order to cancel the order, you either have to replace the transaction with another one with a higher gas cost, which will divert the funds, and then you have to pay 21,000 gas and multiplied by the whatever gas price is, or the other way potentially to remove your transaction from a pool is essentially spam the pool so much that most nodes will actually push it out, which I don't know if people are using it, but it just occurred to me today. And so somebody said in the chat that if there's the case that people are just putting a lot of bids for the lower gas prices, then it might be that this would be the reason why we'll never be able to lower gas prices, because as they get lower, the kind of people buy the dip and then the price go high again. That would be kind of okay, but then I started to look at the magnitude, whether the historically the kind of how much gas has been captured by the minting of those tokens. And so I only looked at the chi token for the last 100 days, and so far I found that the magnitude wasn't consistent with the basically assertion that this is what causes the sort of the gas price to rise, because I think the minting of the chi token consumed anywhere between 1 to 2% of all the gas spent in the blocks. But I would like to see more, and so I am trying to get more kind of detailed data to see whether the minting is actually happening on when the gas price goes down. So let's say that if gas price goes up, then there's no minting, but then the gas price goes down, there's minting. But even then, I don't think we are actually in the magnitude where we could sort of blame this effect for the sustained high gas prices. So that's it. So I hope to come up with more data later.
Okay, thank you very much. Does anyone have any quick comments before we move on? This will just be continued discussion in the Getter, in the not Getter chat, no longer Getter, the Discord All Core Devs chat. Otherwise, okay. Thanks, Alexi. I just realized I screwed up the agenda. I had more things on here that were part of the EIPs that we listed below, and it got screwed up. So I'm going to fix that as we're going through, and then I'll let everyone know when it's refreshed. Like E is missing, and a few like item E and a few other things are missing, so I'll fix that. The
Before we get into that, I want to do the note about YOLO V2 in Berlin because the next three EIPs are related to that. So can I do that first?
Yeah, go right ahead, James. That would be great while I'm fixing this.
Yeah, so I get a lot of questions about Berlin and timing for Berlin, and the reason that I haven't talked much about timing for Berlin is because the first step is to get YOLO V2 together, and then YOLO V2 will decide what will go into Berlin, and there is the possibility that something goes into YOLO V2 and doesn't make it into Berlin. So when we're talking about EIPs that could or could not, that are trying to go into YOLO V2, it is possible that they go into Berlin, but I want to be very clear that it doesn't mean that these EIPs are going into Berlin, but that they're being considered for the testnet first and for client integration testing, and then that will be used to determine their inclusion.
Oh, can I just have a small comment? Is it possible to call it like Berlin V2, for example, instead of YOLO V2? Because that might be a bit more consistent.
I would rather not, because I don't want the clients to write in Berlin into their client code. And it isn't. There are things that could go into YOLO and wouldn't go into Berlin at all. So I think conceptually, I would rather keep them separate. Like one is the hard fork that will be going into mainnet. What YOLO is it's an integration testnet where clients can all build something and then make sure it works together. But they could decide not to have it go into Berlin or not, or go into a hard fork at all. An example is the general purpose transaction types one. Like it would be very unusual to include 2718 without also including a new transaction type. But we could have 2718 be added into YOLO V2 with a dummy transaction type so that all of the clients have the same code together, and integration testing can start happening. So there just is some nuance that I don't want to set expectations to the community that this is a list that is going into Berlin, but we are moving closer and getting closer to Berlin, and I don't want to imply that some of that's.
But what are we going to be calling the testnet after Berlin? I mean, is it going to be some other silly name after that?
The client integration testnets will just do a YOLO V3.
Oh, okay.
We could rename them to something else, but the intention is to do client integration testing, not to do mainnet testing, because
I just thought that if we start to use the name YOLO for the test net, then can we just use something which actually says something like dev testnet or something like that instead of YOLO? I don't understand why we have to use the name YOLO for this.
So if I can add point,
yeah.
So for the YOLO, which is maybe kind of flippant name, but the way I see it is that when we define YOLO V2, then we won't bother with like what's the order between YOLO V1 and YOLO V2 and how do they interact. We just overwrite YOLO V1 and put YOLO V2 in its place, and then Geth will no longer support YOLO V1 and just overwrite. And I mean, we could name it ephemeral blah blah blah, but I think it's good with a name which clearly spells out that this won't be long time supported.
Okay, I see.
Agree with that.
Okay, was that all you needed to talk about, James, for that one?
than intended. But so as we move forward talking about, that's the context I'd like everyone to remember.
Okay, sounds good to me. Are we cool to move on to the next one? Oh, James, you cut out if you were talking.
Button is delaying itself. Yes.
Ah, got it. Okay. Refresh the agenda. I now have better stuff in there, links and more explanation on the EIPs. Okay, so EIP 2718 type transaction envelope. This one is from Micah Zoltu, and it's in draft status right now. This, I believe, is not. Wait, is this eligible for inclusion, James?
I don't think it is, but it should be applying to be. I don't think it's
2718 is eligible for inclusion.
Oh yeah.
At least that was the decision, and I think it was 92.
Yep. Like client's right.
Okay, great. Micah, are you on the call and able to discuss on mic? Oh, I missed all the chat over here. Oh, okay. Micah, are you on a mic? No mic. Okay. So for that one, does anyone want to speak on that? Or if you want to do a quick paragraph typed up, Micah?
I think I could speak, or Piper could speak.
I have a question.
Sure, Martin.
So there's this proposal to add access lists in transactions, and I think that got started out trying to be one of these type transaction thing, and then Micah commented that it actually isn't, if I understood it correctly, and I'm not really sure why that is so. Why it's not considered to be in line with this specification.
Micah's finding a mic, but until then, is there any response that Light Client or Piper can provide?
I can only speculate as to any conversation you had, but it may have been as simple as that there are no formats defined right now that define an access list, that 2718 is purely a format for giving us extensibility in the transaction layer. So you could implement, I guess, a transaction type that had an access list, but I'm not aware of a 2718 type transaction that does that. And it looks like maybe there is one. I see things flowing in through chat, maybe 2930. Martin, does that maybe answer in the direction of your question?
So 2930 was the one I was referring to, and I think, yeah, Micah made a comment on the pull request. Yeah, maybe I misunderstood. I would love to, if someone gives an overview of what's cool about this.
Yeah, so Mike is about to get a mic. Until then, also note that item F is discussion about combining some of these EIPs into a new transaction type, potentially, and I think that might solve some of the confusion, since some of these may seem to overlap, if that's kind of what you're implying. Until then, let's go ahead and do this. Piper, do you want to give an overview of this real quick about what it is, just for everybody?
Yes. So EAP 2718 type transaction envelopes. I'm getting feedback here.
You're good now.
Somebody. Cool. Okay. So it essentially changes the format of the transaction to have an outer envelope and a leading integer that is the type of the transaction. So rather than the transaction being in RLP list of all of the things that we think of as transactions, what we do is we add an extra list around it. Micah, if you want to jump in and take this, you are more than free to.
Sure. Can you guys hear me okay?
Yes.
So as Piper was saying, it's just a envelope that makes it easier for us to have multiple transaction types. So previously, we've always had one transaction type, I believe, through all the history of Ethereum. But we currently have, I think, 2 or 3 or 4 EIPs that want to introduce changes to the transaction. And so the initial idea was, rather than trying to guess what kind of transaction type it is based on how many elements it has, which is, of course, prone to error, because if you happen to create 2 transaction types that have perhaps a variable number of elements or something, you can get overlaps, and you have replay issues where you can replay one transaction type as another. So a bunch of headache is involved if you have multiple transaction types without a mechanism for distinguishing them. So the idea is to just create an envelope that all the envelope has is just an integer that says what transaction type it is, and then a single payload field, RLP encoded, just because that's what we use everywhere else. And that payload field then is how you interpret that is dependent on the initial integer. And so you can now have multiple transaction types, and it's very easy for the clients to figure out what they're looking at. Also, in theory, you could have, I don't know if we'd actually want this, but in theory, you could have some client that actually only speaks certain transaction types, and they can just look at that first field and be like, oh, I don't know what that is, so I'm going to drop it for my pending pool or whatever. I don't think that actually works once you get into runtime, but with some of the EIP 1559 stuff we've been talking about, there is maybe a possibility where we're doing like transaction type upgrades, where some clients may only speak the newer types and they may not actually understand the older types. And that kind of ties into what Alexi was saying with having clients that don't actually know the old EVM. So a similar thing. Again, I don't know if we'd use that as a feature, but it's there. So yeah, just trying to simplify the addition of new transaction types so it's not a headache for every client and developer every time we want to add a new one.
So how do you ensure that? I mean, if you treat transaction as this opaque block, the thing that is signed, I mean, you wrap it with something else, and how can we maintain?
Yeah. So I think I know what you're getting at here. For the legacy transaction type, so for transactions as they currently are, we will wrap them just as they are. So we won't change the signature on them. For every other transaction type that happens after that, the idea is that you should always include the transaction type number in the signature. And so that way you can't run into this replay problem where you can have maybe, where you have to worry about, okay, well, the signature of this maybe kind of aligns with the signature of the other one, because you should always be signing the transaction type as the first item. And so you shouldn't have any overlaps with signatures.
But then the signature is essentially part of the envelope, not part of the payload.
So the signature is included in the payload. It will sign part, sort of yes and no. So the signature is included in the payload. And the reason we do that is because we want to make it so future transaction types could use a different signing algorithm, or they could be a multi-sig, or they could, do something totally different besides signatures. Like we're not just asserting how you have to sign things or how you have to assert legitimacy.
Yeah, but signatures start by hashing the message. If you want to hash it.
But basically what you wind up with is you have this outer identifier, and then you have a payload, and first thing you have in that payload must be the same identifier. So why not just skip the outer one?
So we could definitely, if it's desired, we can we could get rid of the inner wrapping. However, that does mean that we will be stuck with RLP for all future transaction types. The goal with having just the opaque payload as the inner one was making it so, for now we can use RLP for the inner, but if later we wanted to use something else for on the actual encoding, we could. The idea with the signing is when you're signing, you will, for example, 2711 implements this. And so the thing that you sign is the envelope, but you store the signature inside the payload. And this works similar to how transactions work right now, where the transaction that you send, it adds the signature into the thing that you signed. And so you append it on the end, just like we do with the current transactions. And so it is a little bit weird, but it's not out of the ordinary compared to the current system.
I don't agree, because currently we sign a transaction and we append the signature. We don't sign there's no envelope. Whereas in your case, I sign something and then I embed the signature into the thing that I just signed.
Right. Well, so in
I disagree.
like the way that I think about what currently happens is that when you sign, like in the current transaction type, when you sign a transaction, you're basically signing the transaction, but you're signing everything except you pop the signature itself off of the RLP list. And in a 2718 transaction, like when you figure out what the signature hash is, like theoretically, there could be a lot of different ways to figure it out, but they would all basically just involve a kind of either popping off or zeroing out or doing something to kind of take out the signature from the payload.
I wanted to just read out, Thomas has a comment from the chat that you could sign and then extract some of the signed as designed. Makes sense. One is protecting against replay. The other gives a hint on serialization format.
I don't know if we want to. I hate taking up too much time, so let me know if you guys want me to stop. But the one argument I would make that this is effectively the same is because the thing that you sign, you actually are signing the RLP included, or the RLP included transaction, which includes the length prefix, which includes a number of items. And the thing you sign says there's 6 items, but then you jam 3 more in for the signature, and then you change that first number, the length, to 9. And so we are already doing this thing where we're actually changing the thing that we signed after we sign it, because we're adding the signature into the thing we signed. And where you see that is in the RLP length prefix, because that does change from a 6 to a 9 for your current transaction.
Yeah, fair enough.
Okay, so we've gone over this one a bit. I think people mostly understand how it is. One thing that I want to suggest, this was talked about at a Catherders call, Ethereum Catherders call. There's this idea that during times in the core developer call when there's a lot of questions around something, or maybe two similar EIPs or things that are not maybe conflicting ideas or things that need more like clarity, to have like a breakout room in the Discord where we have one of the cat herders organize the people who are around those EIPs and people who have commentary, and collect those people into one chat room to chat it out over the next 2 weeks before the next meeting, so it doesn't have to happen during the meeting. Not that it's not valuable to happen during the meeting, but we only have so much time, etc. So does anyone have any thoughts on that as far as supporting that? Any ideas that might go wrong or anything like that?
Sounds good.
Okay.
It makes perfect sense.
Okay, great. So let's go ahead and go for that. Let's move on to the next EIP so people can kind of talk about it, and then we'll get. Oh, go ahead, James.
Would we consider including it in a YOLO V2 as a group?
Would that depend on the rest of the discussion around the other transaction types?
In my opinion, no.
Okay, so it's not one thing that because you on number F on letter F, it says general discussion on the idea of combining some of the EIPs to create a new transaction type. So if that were to happen, then it wouldn't be in YOLO. So I was thinking, or is that not one of these that would be included?
I don't believe.
I think I put that item up there, and the transaction types that I had in mind were things that would be intended for inclusion after Berlin. So I think I had in mind principally like account abstraction and 1559 and one or two more that are not expected to be in Berlin territory.
Got it. Okay.
My suggestion here is that 2718 not get bundled with anything else so that we can get it in as soon as possible, because we have all of these other things that are going to want to build on top of 2718, and it would be ideal for us to get 2718 out the door with minimal complexity so that we can essentially get it out, get everybody on board with it, and then start building on it in subsequent hard forks.
Excellent. Okay.
It's one of the things that are holding back 1559 development, because if this was accepted, you'd have to redo certain parts of the implementation, but they can't do it until it's implemented, so they know how to redo it.
So this would be good for Berlin, or good for YOLO at minimum.
It would be good for YOLO, and if there was another transaction type going into Berlin, then it would be good for Berlin. But it's at least good for YOLO because then we have client implementations that people can build around.
Okay. So your question, James, was can we put this into YOLO? Is anyone heavily opposed or heavily for or whatever?
Yes.
I am strongly for putting it in the soonest hard fork. I believe it's simple enough and that implementations are underway or beginning to be underway.
Like, from a consensus point of view, like introducing 2017 is right. It's not quite a no. It's not quite a no up because you would still have the transaction type that just is a wrapper over the existing one, right?
Correct. Clients
Correct.
would need to update how they are sort of handling transactions at the network layer, and it'll make some minor modifications to the header in the sense that the computation of the receipt and the structure of the receipt changes slightly as well. So it's not utterly trivial, but I don't believe that we'll find out soon once people start implementing whether or not there's anything hiding in there. But my gut says that there probably isn't.
And as far as is it not? It's not backwards compatible. So once it's introduced, there's no other. So you can't have like a unwrapped transactions of legacy type,
Correct.
right? Okay.
That would be only if it went to mainnet. If it was on YOLO, we could still destroy it.
No, I'm talking about mainnet. So what I'm basically, I think certain proposals in the past were kind of got complicated at the stage when we needed to decide how the actual transitions going to happen. Like at certain, like, because basically what the network nodes have to do, they talk to each other all the time about the transactions, and then sort of it's not necessarily synchronized with the block time. So it's like they can pass each other transactions. Like I'm started a node, I'm downloading some transactions from another node, and then this hard fork block happens as that, oh shit, I need to change the transaction format now. Something like that.
Yeah, so that is mentioned in the EIP. The current EIP says that on the fork block, you will need to do one of two things as a client. Either purge your pending pool or upgrade all the transactions in your pending pool to the new type. And individual clients can choose which of those options they take, but they will need to do one of those as currently defined. And so there will be no more over P2P. There's no more sending legacy transactions unwrapped. You have some wrapped ones. And but Alexei does make a good point that I don't know enough about the clients to say whether that's going to be a problem. So that would be something that would be good to get feedback on.
Those numbers should be very simple to generate. Just the time it takes to re-encode. That's the average size of the transaction pool worth of transactions in the new type. I suspect it is not actually that long, seconds maybe.
And it's something that would be a lot easier to test if we had it on YOLO v2.
Sounds like people want it on YOLO v2, so I think we can say that's a decision made, unless anyone have any objections before we move on. And the great thing about this is, if it doesn't work out, we can pull it from the next YOLO v3 or whatever else. Okay. Number C. EIP 2929, gas cost increases for state access opcodes. That is Vitalik and Martin.
Yeah. So I guess to give a quick description of the EIP, it basically increases the gas cost for first-time accesses within a transaction to any particular storage slot or to any external accounts, including using calls or using the EXT opcodes or whatever, to either 2100 for a storage slot or 2600 for an account. And the justifications for the core justification is basically mitigating against denial of service attacks and making gas costs kind of more accurately reflect computation time. So the the blocks that take the longest to process are the IO heavy ones, and this basically cuts the amount of IO that a worst case block can have by about a factor of 3. The other nice property that this EIP has is that because it only charges for first time accesses, and accesses to the same thing after the first time within one transaction drop to a cost of only 100. There's a lot of it turns out that from some numbers that Martin ran on I think it was the Gurley testnet. So take them with a grain of salt, but they still reflect like real code that people are writing and running. It's looking like gas costs of average applications would only increase by about 2%, and this sounds like very optimistic and crazy, given that we're talking about tripling the gas cost of a major function. But if the core reason why this happens, I think, is basically because, first of all, a lot of applications are written very inefficiently and they just end up S-loading the same thing many times. Second, there's I think Solidity, it's standard to do an ext code size or before you call, and so the gas cost would actually only increase from 1400 to 2600 instead of from 700 to 2600. And then there's a lot of use cases like ERC20s, for example, where you S-load and then S-store the same thing, and the gas cost of those would actually slightly go down under this EIP. So basically, it fairly kind of surgically targets making expensive the thing that needs to be made expensive, but the numbers seem to suggest that gas costs for average usage are not going to change much at all. So that's kind of the core of what the EIP does. And 2930, which introduces access lists, is meant to be a kind of potential companion to 2929. The reason basically is that if any EIP that increases gas costs runs into the risk of causing things that worked before to not work anymore. And the previous round of gas cost increases, 1884, ended up, I think, breaking a couple of contracts. So if we really care about minimizing those risks as much as possible, then 2930 basically allows you to prepay for the gas cost of accessing transactions or accessing accounts or storage slots by putting that in an access list. And so everything from there will just kind of pretend as though the gas cost of accessing things is 100. One thing I forgot to mention is that the gas cost increases kind of exempt calls to precompiles and calls to self. So it actually, I think, ends up superseding a couple and kind of including the functionality of a couple other EIPs that people have been trying to push historically.
Okay. Are there comments on this?
Yes, I have a comment. So I looked at it more closely a couple of days ago and yesterday as well. So in the beginning, I think it was quite a simple proposal, right? It was like 4 things, but of course, right later on, it was expanded to include certain exemptions, and the biggest kind of thing that was added was to exempt the kind of the repeated access, and it's something new that has been added to the, I guess, to the not to the EVM itself, but to the thing around the EVM, which is basically now to maintain the sort of the read list, the read access list, which we did not do before. So because at the moment we only maintain a write list for this EIP 2200, so but now we have to maintain read list for the accounts and read list for the storage, which is, yeah, it's a bit more complications. So I would generally, I understand the motivation for this, but I would generally see this as a not a correct solution, I would say. And the correct solution that I would see is the combination of 2 things. Is essentially, first is the increase the gas cost as you wanted to, but in order to address the problem of like how do you make it viable, instead of introducing this relatively complex exemptions, you can introduce a specialized primitive to address this issue, so that you can kind of cache these things using the EVM code rather than embedding it into the in the EVM to make it. It's like you were adding like a CPU caches inside the CPU, like level 1, level 2, level 3. I mean, I know that it might be a bit longer process, but that's basically my opinion. Is that it's a kind of goes into the same vein with the as the EIP 2200, which I was opposed to, and my alternative suggestion was to introduce the transient storage, and the main objection was that but people have to rewrite their smart contract, and they would never do that. But as we saw recently, they do that all the time, and they migrate, and it actually happens. So I don't really see this as if there is a correct primitives in the EVM to make these things viable, they probably will use it.
And I think, like, I don't know, I definitely rate the complexity as being kind of, I guess, lower than that. My basic, like the place where I'm coming from is basically that, like, the thing that this introduces is like that this uses is this kind of concept of transaction-wide global variables. And there's like, yes, transaction-wide global variables are tough, and like, you know, we have to deal with like the rules for reverting them and so forth, but we've basically already figured all of that logic out. So like, for example, we have refunds, which is a transaction-wide global integer. We have self-destructs, which is a transaction-wide global set. So it is implementable kind of entirely using existing data structures. Now, like, I mean, if there is a proposal for what alternative solution there is that can kind of capture behaviors around, like, say, ext code sizing an account and then calling it while paying the gas cost once. Like, I'd be interested in hearing it, but my instinct that, like, there is value in having this out in kind of the fairly short term, and like, basically,
yeah, my main proposal for any of these sort of things so basically the problem that we're trying to solve with these exemptions is that obviously if the information is kept within the same execution frame, then you can simply keep it on a stack, right? So you don't need exemptions. You can just read the stuff and then you keep it and then you reuse it from the stack rather than rereading. But what the problem that you're trying to solve is that what if you are reading the same information, but from the different execution stack, from the different, so from the sub call. So let's say that this this particular, Xcode cache was called in this execution frame, but then you called something else, and then it calls the same it calls the same contract or account, then you basically give exemption. And I have, so first of all, is this really important? My first question is that, do people actually do that quite often? Maybe they don't, because I don't see the point of doing it so much. And secondly, if they actually do that, I would rather, again, introduce the mechanism for that, rather than basically what I'm, it's rather than making those operations more complicated. I was against introducing a kind of really sophisticated gas pricing rules for opcodes, and now they're becoming even more complicated, it seems, especially for the read operations.
So I don't quite agree. One thing you mentioned is like, do people do that? And like Vitalik mentioned, Solidity does it every time you make a call. It does an Xcode hash first, and then it does the actual call. And in many cases, the actual cost of that Xcode hash plus the call do not actually equate what's going on under the hood. And we're not actually adding another cache layer here. What we're adding is just Boolean, basically. Have this been accessed in this context or not? And I think it's simple. the mechanisms of this ETH are simpler than the net store gas changes, which has to track the origin value, the current value, and do juggling with those variations of what they can be. Implementation wise, this I thought it actually turned out pretty, I mean, not trivial, but at least not too hard, actually, not too invasive.
So, and another thing to keep in mind is that, Nick, if we're talking about implementation of alternatives that would actually require contracts to use different primitives, then, like, for example, if you want to get the gains of not double charging for an S store followed by an S load, which is what ERC20 tokens do twice in every transaction, then like you pretty much have to redeploy every ERC20 token. So.
Okay, so yeah, so I was going to say that my main concern was not about the performance of this stuff, because I think performance could be achieved pretty easily. My main concern was about obviously complexity, because I did find that, I mean, as Martin said, it probably a different case, but I did find one of the reasons I was really hating the self-destruct and things like that, and then is because it's just enormously complicated to get right, especially if you want to modify that code a little bit, and the things just start falling out. And so this particular EIP, I guess you could simplify it by saying that
Hey, did we lose Alexi?
reverts.
Oh, there we go. He's back.
Yeah. So yeah. So I think that's. Oh yeah. Actually, I have I just pushed on my internet cable. So yeah. So basically, if we say that this this kind of cache that doesn't, it survives all the reverts, then probably it will be easier, because a lot of the complexity comes with what happens if I do this, but then I do undo that and then do it again and so forth. Do you think that is specified already?
Like these are things that we've already done is the thing, right? Like we already have a transaction-wide set, which is like basically, which is like the list of self-destructs, and then we have an integer, which is the reverts. And I mean, like we basically ironed out all those consensus issues in 2016.
Oh no, I
Yeah,
understand
and Alexia, I totally share all those concerns, and that's why I did an actual implementation of it to see how bad it would be and how invasive it would be. So I urge to take a look at how it became in the end.
Okay.
It all uses, I mean, it utilizes the same things that we already have for rolling, but the journaling mechanisms and rolling them back.
Yeah, the thing is, I wanted to find a way not to use a journaling mechanism, and this is where it got really complicated, because I did I do believe that the journaling mechanism is itself too complicated. So, but yeah, I will try.
Great. I'm just time boxing this real quick. If you can move this to discussion on the Magician's thread, and if you want to request a breakout room in the Discord for this, for further discussion, just come to me or Pooja or Edson from the Catherders, and we can set you all up with one and get people corralled in there. So thanks for that one. That was 2929, right? Yes. So 2930 would be optional access list, and that one is also Vitalik and Martin.
Yeah, so, and I brought up 2930 just briefly when talking about 2929. The idea is basically that it allows you to prepay the higher gas cost for accessing storage slots and addresses for the first time. And this is intended both as a mitigation to the risk that 2029 would break contracts that have higher gas, or that rely on fixed gas limits, which there likely aren't many, but maybe a couple, kind of similarly to what we saw in 1884. And it's also basically a stepping stone toward having that access list infrastructure in there, which could be used for other things.
Okay. Any comments on this real quick?
Do you want to consider them for EFI?
Or is it too early? Yeah.
Is it at that stage?
I mean, the EIP itself is not super complex, and like if we want to have one transaction type, I guess. So what's the calculus? Like one thing is that if we want to have one other transaction type along with 2718, then this is probably the simplest one to include. The second thing is that from a perspective of like if you really care about making sure that 2929 doesn't end up like breaking any existing contracts, then if you do 2930 at the same time, then you're completely fine. If you delay 2930 by one hard fork, then like basically those contracts could just be accessed after that second hard fork. Which,
Yeah, I just like to mention also that I mean I would love it if we could spin up a network with this. If one other client would also care to implement it, then we could just try it out and see if the implementations are correct. And think it would be really good. So I'm all for having it as YOLO v2 or just some little tiny, I don't know, never mind, testnet or whatever.
Yeah, I was gonna say if perhaps that means it's a good fit for going into YOLO v2 for just that purpose.
Yeah, and we actually skipped asking that question about 2929, but it sounds like 2929 and 2930 would be a good combo to put into YOLO v2. Am I reading that right, or would that not be good?
I'd say yes, but I'd want to hear others' thoughts on that.
I feel like it would be simpler to have it all in YOLO v2 rather than manage these two testnets in parallel. But it's not a super strongly held opinion.
Would OE, Nethermind, or Besu, do you all have strong opinions on implementing these as far as either complexity concerns or kind of roadmap concerns for what you're doing right now? Would this be something you'd be cool with putting in?
Yeah, I was thinking about like if we stop filtering those, then YOLO v2 might be so big that it will be hard to implement everything, especially with the assumption that only some of them will go to the actual production chain, mainnet chain. I mean, I like most of the proposals and I understand why they're introduced. I'm not super convinced yet by the optional access list usability at this stage without anything that follows up. And I think this will be redesigned a lot before we actually start using it, but maybe I'm wrong here. I mean, not particularly would like to see 2935 in Nethermind for other reasons. Yeah, everything else seems to be relatively simple, or we already have it.
Okay. Anyone else, Besu or Open Ethereum? Or actually Trinity too. Sorry, I forget that sometimes.
Sorry, say again, what's the question?
Oh, the question is, from what we've talked about so far, so 2929 and 2930 in particular, are there concerns with complexity or implementing this into something like YOLO v2 from anyone's perspective?
I honestly, I cannot answer this question before looking at more deeply into this EAPS myself, so can't answer right now.
Since we already decided YOLO v2 should probably have 2718, and that's going to take some time to implement anyway and hash out a little bit in the comments. Let's do 2929 and 2930 on hold as my suggestion. James, do you have a thought?
I'd like to just put them in as trying to get into YOLO v2, but not accepted yet.
Yeah, that's kind of what that's what I was implying.
Yep. So 2929 and 2930 will go on the list of stuff to figure out if we get into YOLO v2.
Cool. 2718 is YOLO v2 currently. The next EI. Yeah, go ahead.
Oh, I was gonna. Oh, sorry.
Go ahead, Tim.
Yeah, Tim,
Okay.
you go first.
Yeah, I was gonna say, like, I guess based on Thomas and Vitalik's comment about 2029 and 2930, 2029 feels like it might be something we want to do. Like it's easier to say it's in YOLO v2, because if we put it in like this awkward in between states, then it becomes hard to figure out what is YOLO v2. So I would push towards having 2929 in YOLO v2, and then for 2930 we can just wait and see. And you know, worst case, if other things are more important or come up and whatnot, we can deploy it in the next upgrade, and you know, it is a possibility. Yeah.
Thomas is saying the same thing in chat about 2029, so I'm fine with moving that in, as they said.
Cool, I'm good with that. Anybody else?
So it's which tools have been or will be changed to support the new transaction formats, and more importantly, the optional access list. Because it's one thing that clients support the feature in the YOLO testnet. What ways could devs and users submit transactions? Which tools are going to support these?
So I can speak on.
Yeah, go ahead.
Go ahead, Micah.
I can speak on 2718 real quick. So the transaction types, the clients can do the upgrades for transaction type 0. And so for transaction type 0, so which is the legacy transaction type, applications that are talking over JSON RPC can continue speaking the exact same protocol they've been. And then when the client receives that over JSON RPC, they would upgrade it to the new transaction type 0 envelope transaction and then send that over dev P2P. So only Ethereum clients should need to do 2718. Once we start adding the other ones in, then yes, we'll need to get app developers will need to integrate, and we'll need to have a new JSON RPC endpoint, stuff like that. But just for 2718, app developers don't need to do anything. JSON RPC shouldn't need to change for when we're only supporting the legacy type wrap.
Martin, did you have something, or was that what you were going to echo?
No, I was going to say that basically for the emergency case that you need to unbreak a contract flow, you need to add an access list. There doesn't need to exist tools that, I mean, all the tools don't need to support access lists. As long as it is possible for someone who's somewhat technical to use a tool that has it. Now, if you want a more general rollout that everything uses access list because it's cheaper and we have a little bit of rebate on the gas there, yeah, it of course will need more support in all the various tools that people use to make the transactions.
I just mean the point of having it on the testnet is so that it can be actually tested across the client. So there needs to be some kind of a tool which supports the access list option.
Right. Yeah. Well, basically, I mean, I guess any client which has its own key handling and transaction creation. I'm not that well versed, but I mean, Geth has it. I know Parity has it. I suppose that the other nodes has it too. They would probably build something.
So Go Ethereum would just have it transparently added through the RPC method.
Yeah,
the same transaction.
Some way, shape, or form, I guess. Yes.
Would that be ready for the YOLO v2? Is that something we should plan for?
Yeah, I mean, I have implemented the first part, which is the changes in consensus. I have not yet looked at actually implementing the new transaction type. So I can't really say, but I would suppose that, yeah, if we do the new transaction type, but then we also have to add the new endpoint to create such a transaction. But I don't know how long that will take because I haven't done it yet.
And just a last question on that. Is there any kind of test suite for transactions today in the Ethereum tests?
Yes, there are transaction tests. I think they were kind of introduced when we changed the transaction format with ETH 155.
So at least we could have a set with the access list.
Okay, any other comments? Okay, so 2929 going into YOLO v2, 2930 still discussing. The next item on the agenda is EIP 2315, simple subroutines for the EVM. That one I believe is already. No, wait, that is not in YOLO yet, right?
In YOLO v1.
You're saying it's not in YOLO v1. Okay.
Yeah,
It is in YOLO v1.
it is.
Oh, it
It
is.
is in YOLO v1.
Okay. So that'll just go over into YOLO v2, it looks like. So I don't even know. Are there any updates to that EIP? I think that was Greg's and Martin's.
Well, the only update I have is that we did write the custom fuzzer targeting subroutine, the subroutine implementations, and that particular fuzzer has not yielded any results as in, findings. Yeah.
So that's a good thing.
Yes.
Yep. Okay, great. We'll move on. Oh, go
I
ahead.
didn't quite hear what you said, Martin.
I said that there was a custom fuzzer written to target the subroutine implementations.
Okay.
And yeah, found no issues with the implementations.
And there was one last feature we were discussing on not jumping into subroutines, which I'd like to discuss if it could go in. I'm a bit more liking it than I used to. I recently read over everything that was written about it.
Okay. Is that something that should continue in the Magician's thread, in your opinion?
Yeah, I put an entry there to get it going again.
Okay, great. So that one
no
is.
one noticed.
Yeah. So I'm going to say for this one, I'm taking notes on some of the decisions made. So I'm going to say for the simple subroutines, continue discussion in ETH Magicians. Okay. The next item is the general discussion for combining some of the above EIPs into a new transaction type. I know that Light Client and James were talking in the Zoom chat a little bit to clear things up on that. What came of that? Is this still an item we need to discuss, or are we kind of clear on it?
I don't think we got to anything clear, but I also don't know if we have the time to really get into it.
Okay, let's skip it for now because we're still. That might be something that coalesces naturally as we have the breakout room and stuff like that.
Yeah, I'd like to hear if that's all right with Light Client before we move on to.
Sure.
But yeah.
Yep, that's fine.
Okay. Next up, we have EIP 2935, save historical block hashes and state. This one is Vitalik.
Yeah, so, and I can make this quick. The basic idea of the EIP is that you just stick the block hash into the storage of a particular contract before you stick the hash of the previous block into a storage slot before processing the current block, and so you just have a contract that just maintains an ever-growing history of storage hashes. So very simple and dumb, just way of ensuring that blocks have a quick Merkle path to all historical blocks, at least since the EIP was introduced. I mean, in terms of state size growth, it would add something like 2.5 million storage slots per year, which is, I think, like a gain of relative, like 1% relative to the current storage size. So it's actually not even particularly large. And the main benefit, and there's a lot of different applications that benefit from this, but they're generally in the category of creating layer 2 protocols that allow users to prove things about history to other users, and so reduce the need for people to personally store historical information.
Comments on this?
But so if you're going to prove some header, like start some historical header, you would need to rely on the fact that your state root is correct, right? And if you want to figure out the state root is correct, you have to verify the whole chain of headers from the beginning. So it's kind of circular.
No, well, so not quite, right? Because So first of all, if you're a light client now, then you're already relying on one of these kind of, well, okay, what you can do is there are protocols that allow you to verify a proof of work subchain, right? So you can basically like just look at a provided subset of headers that match a 100x difficulty threshold or something like this. So there are and there are things that you can do, and the other thing is that as a client you might have downloaded verified the header chain historically, but like you might not want to keep it around.
Okay, I would like to, and I think we have considered that in the past, but the reason I said, I guess it wasn't really, it didn't go in because we could not find kind of appealing use cases for it. So yeah.
No, it's like I was actually talking to people from gas station network and Yoav about this, and he is really excited and intent about something like this going in. So I don't know, maybe I should set up a chat with him.
Well, essentially, like the gas station network, for example. I mean, I don't know. Like, is there a problem that I can't run a node or something, or I don't.
Like they are in just looking into history related things. So
Vitalik, is this in any way like an alternate direction from putting a header, an accumulator in the header itself?
It is just, and it does do similar things. It is just simpler and dumber, like because it's probably literally under 5 lines of code in the context of the existing Ethereum protocol.
So Thomas, you had a comment in the Zoom chat that there would be some DeFi solutions around this.
Yeah, we have some projects that we're building that would greatly benefit from 2935 being available. So that will save a lot of gas and unlock some additional opportunities for pricing and delivering products.
Because this discussion's kind of on why now, right? Is that what you were getting at, Alexi, or why in general?
Well, yeah, because I just kind of remember that we spent a huge amount of time in the past discussing the similar proposal, and in the end, so I kept asking the question, why are we doing this? And in the end, we couldn't find we were thinking that we're doing it for this reason, but then it turned out there wasn't really anybody who could tell us like what was the reason. So I don't want to do the same thing. So if yeah.
Is it correct that under this proposal, if you have a recent header, then you could provide a Merkle proof that some arbitrary historical header from history is part of the canonical chain behind that header?
Yes.
Because that alone is a huge benefit for the protocol itself, because it means that it allows clients to actually forget the header chain, and it allows us to prove historical canonical blocks, which today, if you really want to have, real deep knowledge about the whole history, you have to keep the whole header chain, which is, multiple gigabytes. That alone is a objectively valuable reason to have this.
So does this go on the list of things that'd be good to do for YOLO v2 so we could look at it integration wise?
Yeah, we would love to see it in YOLO v2. We can even provide some use cases and start showcasing them maybe in YOLO v2 already.
What was that, Alexi?
No, I just wanted to basically be kind of to keep an eye on the number of items you want to include in YOLO v2, and I don't remember what was the exact purpose. Is that do you want to kind of unbundle them later to try to put them into different upgrades? Because I could see that we're doing the same mistake that we did before, is that kind of having this wild enthusiasm to put a lot of things in, but then realize, oh, actually, we can't do them all together. We have to start splitting them up. So I think it's fine to look at the proposals, but it doesn't mean that we have to pile them up in the same release.
Yeah, that's actually exactly why we're putting them into YOLO instead of saying let's put them in a test net going into Berlin. Because we've had bottlenecks before of a lot of the arguments I find with EIPs come down to we don't have real like implementations that can be tested across clients to see different benchmarking metrics, for instance. So putting them in YOLO allows us to do that because then we have cross-client testing of these things before we decide if it's actually going in or not, for things that are very much wanted, but we haven't gotten all of the kinks out yet. So that's kind of why I think YOLO is important. There's also other perspectives of why YOLO is important, but that's kind of where I come from.
Okay, so it was my sort of misunderstanding what the YOLO is, because it's sort of like it's not just simply some ephemeral testnet, but it's this kind of pile of things that just whatever you can just put whatever you want in there.
Yeah, and then version 3 we can take crap out, version 4 we can put stuff in, etc. It's just a easier way to say we're not having we're not messing up, or not messing up I guess is the right phrase, but we're not affecting things like Ropsten or Goerli permanently while people are using them, but we're still getting the things like benchmarking and other benefits out of it, these ephemeral testnets as we're calling them.
It only lives once. Sorry, I had to do it.
Does that answer your question, Alexi?
Yeah, that's fine. Thank you.
Okay. And there's always a chance that we can do other strategies in the future, but we've I think having these YOLO testnets are a good opportunity for rapid testing of, well, not real testing, but rapid examples of these EIPs going into actual client code.
The only concern with that is that essentially what you're doing by bunching up lots of things in it, you essentially make it mandatory for anybody who wants to join YOLO to implement all the changes that have been that were put in. So that's why. So there's like if you put 10 EIPs into YOLO v2, then unless you implement all 10 of them, you will be kicked out of it pretty soon, because I suppose that you're not going to implement all of them.
And yeah, and the thing is, for more advanced EIPs like 1559, that's going to be different than like optional acts, or what was it, 2929, because one of them is much more simple complexity wise. So the reason a lot of them are going in and we're talking about a lot of them are because the complexity around them are pretty small, in my opinion, from what people have said.
Yeah. I think if the only reason I suggested 2935 is basically just because it literally is 2 lines of specification, which is so it's not really a kind of a one-to-one comparable against, like, say, and it's some new cryptography precompile or whatever.
Oh, Micah, you might be right. I don't know the complexity of 1559, but that might come up in a little bit if we get to the update.
And that's why in the conversation I'm asking the clients if we like to get them in, and if a client feels strongly not to have something because it increases the complexity too much, please express that.
And the other thing is, for the ones who haven't had a chance to look over this a lot, so if you're a client and you're not comfortable yet saying put it in or don't put it in, you can go into the chat afterwards in the next day or two and just say, hey, I changed my mind, or hey, let's rethink this, and we can talk about it in chat. So that's not like, the decisions we make here should stay, but if there turns out that we need to change our mind after the fact because of an extenuating circumstance or a misunderstanding, that's not the end of the world.
Yeah, that's another benefit of it being around YOLO, is it's we can undo things also as easier.
Okay, so next up we have EIP 2711, sponsored, expiring, and batch transactions. That one is Micah.
I would suggest that we table this one, and unless Micah feels strongly, simply because we already have a lot of stuff on the table, and maybe we want to get 2718 in place first before we tack on extra stuff on top of it, but I'm totally fine with presenting it as like, this is something that's coming.
Micah, what are your thoughts?
I'm okay with either giving a quick overview for those who haven't read it, or just saying go read the EIP, or discussing it, whatever you guys think.
My opinion is to give an overview, but we are explicitly saying this is not to be considered for anything today, including YOLO, and this is an overview just to give people an overview, so it may be discussed in future meetings. So yeah, Michael, you can go ahead.
Works for me. So this was originally supposed to be the first type 2718 type transaction. Since then, there's been several others that are probably going to make it in first. But the idea is to give a new transaction type that addresses just a handful of user experience nuisances that kind of cause problems in the dApp space. So it would do a few things. One is sponsor transactions. So instead of having a single signer on the transaction, you would have up to 2 signers. So you can either have 1 signer like normal, or you can have 2 signers. The second signer is the one who pays for gas. And the idea here is someone who you can use some layer 2 mechanism or off-chain mechanism, or you're paying someone with PayPal or whatever, it doesn't matter, but they pay for your gas. And so you would sign a transaction that goes inside of an envelope, basically, and then someone else would pay for that. And so it solves, I believe people are calling it meta transactions, but it solves them at layer 1, which ends up being a whole lot cleaner than trying to solve them in the dApp layer. The other thing it adds is batch transactions. The idea here is you can do 1 or more transactions, and they will be atomic in the sense that all of them will make it in the order you specify with nothing in between. They're not atomic in the sense that they will all fail or they will all succeed. What this does is it solves the horrific UX problem of ERC20 approvals, which we actually see elsewhere besides just ERC20. So instead of users having to sign a transaction that says, I approve this app to spend my stuff, and then wait for that to mine, usually, and then sign a second transaction, which then says, okay, now app, go do this thing. You can just sign a single transaction that basically does 2 things in a row. And so it's a simple, it's a little bit of overlap there with account abstraction. Like if we already had account abstraction, then this probably wouldn't matter much. But account abstraction, I personally feel like, is much farther away, whereas batch transactions are pretty easy once we have 2718 in. Third thing it does is adds an optional expiration field, which basically means this transaction is no longer valid after a certain timestamp. And so everybody can just drop it from their pending pool after that timestamp. We see apps, multiple apps in the ecosystem are building this into their contracts. Uniswap being the canonical example, where they include a deadline, which is defaults to 20 minutes in the future. And if your transaction doesn't make it in time, then your transaction still lands on the chain currently, because that's how it works, but it just fails instantly. And this results in just a huge amount of wasted gas, with frustrating for both users because they're spending gas and nothing's happening. It's a no-op essentially. And it's causing some amount of the gas usage or gas price problem. And so expiring transactions would just allow us to have a mechanism for dropping transactions. That one's probably the most contentious, honestly, because it theoretically introduces a DOS attack vector where you can submit transactions that expire like 1 second in the future, which is just enough time for the nodes to propagate them, which is waste a bunch of network bandwidth, and then drop them, so they never actually make it. We could maybe, nodes can do things about that, such as saying, I will just refuse to accept any transactions that aren't at least 10 seconds in the future. But that's the one thing that's maybe contentious, I think. I think the rest of it, I don't think there's any real issues with it. Again, mostly to solve UX problems at the dApp layer, the things that have been frustrating users for years now. That's the summary.
Question?
Martin, did you have something?
Yes, so I'm curious about batch transactions. So right now, a transaction, whether it's valid or not, it's pretty easy to determine. Is it nonce right, and does it have balance, basically? And if you have batch transactions, then you could have like 9 transactions in a row, which are fine, and then comes number 10. And depending on what happened on transaction number 9, makes transaction number 10 invalid because it maybe removed some balance. That sounds like a DOS.
So I believe, and we can talk about this offline if you disagree with this, but I believe that is actually solved by the fact that there's one gas payment for the entire batch. So you don't pay gas per individual transaction, you pay for the whole batch. And so either and you can deduct that before the transactions start, right? Because as we always do, we deduct the gas first, and then we execute the transactions, I believe. And so it'd be the same thing. So you deduct the gas first, then you'd execute all the transactions. And if they run out of ETH halfway through, it just means maybe some of those transactions start failing, but you've already paid for the gas for all that upfront.
Actually, one thing I'm curious, how does this multiple transaction thing interact with global variables? So like, are things like the refund counter and the self-destruct list processed at the end of every one of these sub-transactions, or only at the end of the whole batch?
That is a question that someone more intimately familiar with how clients are implemented would need to answer, and I have not addressed in the IP currently. So definitely, if someone knows the answer to that, let me know, and I can update the IP to include that, or we can change it as necessary to make that work. I don't know.
Well, so the refund, self-destruct, and etc. mechanisms are one of the most perverted parts of the EVM. So if we go down the path of introducing batch transactions, I would really strongly vote towards keeping every current mechanism. So essentially, we would just execute one transaction after the other, but otherwise they would be as if they were separate individual transactions, because otherwise we're just shooting ourselves in the foot with the extra corner cases.
Right, I agree about that. But then you land in the problem again that what if you have 9 batch transactions and then comes number 10, which is invalid because it tries to send 1,000 Ether and doesn't have anything. And that means you can't do anything with a whole batch.
Wait, another just kind of zoom out general question. Have we thought about like if the intended use case is things like making it easier to do the approve a token and then use a token workflow, the alternative, which is like basically allowing top level like EOAs to basically delegate calls. So allowing top level EOAs to just temporarily run a piece of code from their context so they'd be able to do multiple calls.
There's actually an EAP out for that. So yes, that is an option. And if we had that, it might actually make batch transactions not a thing. My main concern with the main reason it was added here is just because I think all the other solutions to that problem I believed were more complicated. However, I might be missing something here, such as you guys were talking about the self-destruct and whatnot, that makes this actually much harder, and it would be easier to just allow EOAs to do execute delegate code, in which case we could drop batch from this.
Yeah. But by the way, if anyone knows the EIP number for letting EOAs run code, you can just like paste it to chat. I'd be happy to just look at it.
Okay. Anything else on this?
So Micah, you meant the rich transactions, or you meant which is 2803, or the other one from the transaction package, which I guess is competing with your work as well.
I believe rich transactions is the one I'm thinking of. There was someone else who wanted a slightly different implementation, so I think they also submitted an EIP. The one I'm thinking of is 2803.
Yeah, I actually had as part of what we call the E2X64, we had a modified version of that because the current version of rich transactions uses some precompiles. But I think it's a much simpler option than having these transactions. Anyway, I have a question regarding how would any of these transaction types, the feature set combine? So there's the access list. How would any of that combine with your proposed transaction types? Is that we would need to come up with new transaction types for all these different combinations?
Yeah, that was discussion item F that we skipped over, basically. There's definitely, one can imagine a situation where you would want to do both, a batch transaction plus include an access list, like that makes sense, or you want an expiring transaction plus an access list. So it kind of makes more sense to combine these if we can. Whether we do that or not is probably a bigger discussion than we have time for. I do think we should have it though, because I think it does matter.
Great. I got to time box this, but thanks so much for the overview, Micah. And we'll move on to the next item. EIP 1057, next steps. I think, Greg, you had told me in chat that instead of going into any decisions today, because there was some further feedback behind the scenes that you just wanted to give just an update, right? And then you also posted a comment in the agenda.
Yeah, there's a long comment in the agenda we don't need to get into for a couple weeks. Andrea, one of the authors, got out of the hospital a couple weeks ago, so he's reviewing the code he wrote before he went into the hospital. On the old kick exploit, we are really coming to the decision that there's no exploit there, that it would be so difficult to exploit. And even if you did, the other miners would look at your blocks and say, no, we won't accept these. So we're looking at the general area that he was in, but we're not sure there's anything there to worry about. And that will simplify the proposal. And otherwise, it's under review. We can talk about it some more at the next meeting. As far as any hurry, existing ASICs will start falling off of the network probably November, based on the block number and based on when the DAG gets too big. So that'll be the first time that we would want to deploy ProgBW if we do. So next time.
Okay, thanks, Greg. The next item 2A, YOLO/YOLO v2 and Berlin State Test update. I've been writing down which ones are going into YOLO v2 versus which ones aren't going into YOLO v2 and which ones will just be continued discussion. So I just wanted to read those off if that's okay with you, James.
Yep, and there's one more I wanted to talk about of that.
Okay, so just reading these off just to confirm, and anyone speak up if this is inaccurate. Add EIP 2718 type transaction envelope to YOLO v2. Add EIP 2929 gas cost increases for state access opcodes to YOLO v2. Continue discussion of EIP 2930 optional access list, so that is not added to YOLO v2. Continue discussion of EIP 2315 simple subroutines for the EVM and the Ethereum Magicians forums. That one is already in YOLO v1. Add EIP 2935 save historical block hashes and state to YOLO v2. EIP 2711 sponsored expiring and batch transactions was only discussed today as an overview for the purpose of future discussion and not to be considered for inclusion, EFI, or anything else at this meeting. So those will all go into the decisions made category in the notes. And I'll paste that into the Zoom chat for the note taker today. And then there was something else, and I won't do that till James is done with his comment, just in case I need to add anything else. So James, you can go ahead.
First, that matches my notes as well. The two that are left to talk about is 2565, the repricing of mod XP precompile, which I think is pretty safe to say that it should go into YOLO v2.
Yeah,
and I can provide a quick update there, James. So just as a quick update on that, that's moving into final status as an EIP. Micah has provided some good commentary just to clarify and sort of make it more spec focused. There's an implementation in Open Ethereum. I provided some comments on a pull request to make sure that's compliant with the final specification. And then I also have a gist for how to implement it into Geth, and I will paste that into all core devs as well.
Great. Any comments on that from anybody? Anybody against putting that into YOLO v2 for any reason or anything like that? Okay. What was the other one, James?
2046, reduced gas calls for static calls made to precompiles.
Who was that?
That is Alex, is EIP, and it's just been on the proposed for a while, and that's the last.
That's the one for static call. Okay.
For that one, if we did the what is it, 2929, it would be reduced to 100 because the precompiles are already in the access list.
Okay, so 2046. If we did 2929, it would supersede 2046.
Yeah, I think so.
Okay.
It's more a matter of whether Like if 2929 goes into YOLO but not going into Berlin, 2046 can still go into Berlin because there are no blocks for this. It will become a change of constant, which will be absorbed by 2929 going in at any time after, if it doesn't go into Berlin. I mean, the only thing which stopped 2046 from being kind of included already quite some time was one particular precompile call in gas, which is fixed by UPR, which should speed it up 3 times. So there is no longer a problem that some precompiles will become underpriced if call cost is reduced.
So then do we have both of them in YOLO, or do we say we have 2929 in YOLO, but there is an option of doing 2046 in Berlin if 2929 doesn't make it to the end?
I just wanted to say that those can be treated separately, whether 2929 goes into Berlin or not, and how it will happen, it will most likely depend on implementation and testing.
Okay, so do I leave it in the pending list or do I put it into the YOLO v2 list?
First, let's get opinions. Who has thoughts?
I proposed 2046 initially, and of course I would be happy if it would go in. But at the same time, if we do have 2929 and it accomplishes the same without adding less rules or less changes to the rules, then I would personally prefer to go that route. Because if we do 2046 and then we do 2929, then we have these two separate changes added to the system, which may be unnecessary.
So then we keep it as pending as we're looking at 2929 in YOLO v2. That's what that sounds like to me.
That sounds good to me.
Okay.
Anybody else have a comment on that? Okay. I'll paste all the decisions made stuff that I mentioned into the chat. We'll probably go over a few minutes in time if people can stick around. If not, feel free to drop. But we had 2 more things. One of them was the EIP 1559 update, and the other was an update on the account abstraction EIP and denial of service study. So first, EIP 1559 update. I think that was Tim.
Yeah, sorry, I'm having a bit of an internet issue. Can we do the other update before? It should be fixed in like 2-3 minutes.
Yeah, sure. So next one is Will, and it's account abstraction, the EIP and the DOS study. If you click in the agenda, the comment has links to both of those. And Will, go ahead.
Yeah, cool. Just want to briefly mention it. I think in the next all core devs, we want to actually have a more thorough discussion. But one of the bigger concerns around account abstraction in general in the direction were basically the DOS vectors that and the vulnerabilities around that. So we released a study on ETH Research that goes into the various DOS vectors. We built a basic version of account abstraction into Geth, and we collected a bunch of data on what the impact would be and how that would affect something like AA if that were to be included in the Ethereum network. So definitely recommend people go through that. And in general, it's a interesting case study on the transaction pool in general within Geth and looks at things that are not just AA related as well. So there's probably some interesting content there. Regarding the EIP, Vitalik posted that, so I'll let him talk about that, him or Ansgar. Yeah, passing that off.
So I think in account abstraction, like we've talked about the idea in a lot of different forms and different contexts, but basically the goal is to allow or expands the set of conditions that transactions can have for their validity for inclusion in the chain. So basically conditions where that determine how or conditions that determine basically whether or not a transaction is even valid in the first place. Whereas currently that's restricted to being just an ECDSA signature and a nonce check. And there's a whole bunch of different use cases for this, but we kind of break them down into two major tiers. One tier is what we call single tenant account abstraction, which basically is mostly smart contract wallets, multi-sigs, new signature algorithms and various things like that. And multi-tenant has to do with applications that become represented by single accounts. And so we figured out a roadmap that basically implements the single tenant account abstraction. So basically allowing smart contracts that satisfy particular conditions to be top level accounts that execution or transaction execution starts from first, and then expanding out to a multi-tenant over time, where and in general, the set of consensus changes is fairly small. It's largely changes to a minor strategy and network relaying strategy. But this is the thing that Will has written a big denial of service study that's available on ETH Research, and there's a lot of arguments in the EIP as well. So to clarify, this is definitely too complex and much too new to be considered for Berlin, but likely some point after that, and I guess the EIP is there and it's kind of ready for more people to look at.
Okay, any other comments on this? And we can add this in future agendas. Okay. Tim, are you back for EIP 1559?
Sure, yeah. So I shared the update, I think, on the agenda, but we had a call last week, an implementers call. So just give a quick overview of where things are at. Right now we have a testnet between the Besu and Geth implementation, which is being done by Vulcanize. It's still finding some corner cases with the spec and whatnot. So it's been good to just test things in consensus. We also have the EF doing some simulations on the EAP. So Barnaby from the EF first worked on just trying to simulate what it looks like when there's spikes in transactions and how do they resolve over time. And now he's going to start working on some more complex models around having agents trying to outbid each other and having just a bit more elaborate strategies. Another thing that got announced in the past couple of weeks is Tim Roughgarden, who's a game theory and computer science researcher at Columbia, is going to be doing a formal analysis of the EAP and mostly trying to compare kind of the design of the EAP with what we currently have on mainnet and other proposals like the escalator fees. Next steps from here is to get more client implementations and probably start running a small proof of work testnet while the research is continuing. There's a bunch of potential changes that are being discussed for the EAP, so we're trying to just move things forward and incorporate those as it makes sense. 2718 was one of those, so it's good that there's some resolution on that. Yeah, I think that's pretty much it. I don't know, James, do you have any other updates?
James, you're on mute, maybe. We can't hear you.
Yeah.
I'm on mute.
Yep, you're good now.
I was saying a funding update, but I don't know if we need to go into that. We're already pretty over.
Yeah, we're over time. So yeah, just pasted the decisions made. The note taker has gotten those. Next time, we're going to be adding account abstraction to the All Core Dev meeting agenda. We'll also be adding the Ethereum Catherders survey results to the All Core Dev agenda next time. Pooja has already started in the ETH R&D Discord, the breakout room, and has tagged people who may want to be in there for that discussion. And they're going to be setting up, there's different times to have a real voice meeting on that have been suggested. So please vote on the suggested date and times in there. If you've been tagged or if you want to attend, anyone's welcome. If you aren't in the Discord server, in the agenda, there is a link to the Discord server. I think actually, if there isn't, just find me or find someone who can give you a link. I have a link and or an invite code, and I can give it to you. All right, thanks everybody. This went a little over, but I think it was really productive, and we will see you in 2 weeks on September 17th, 2020 at 1400 UTC. Have a great weekend, everybody.
Thanks.
Thank you.
Thanks, Hudson. Shout outs to people.
Thanks. Bye-bye.
Thanks. Thank you.